NASA didn't see this. James Webb missed it. A mysterious tail emerging from an interstellar object thought to be dead, not captured by billion-dollar telescopes, but by a small observatory deep in the mountains of Brazil. A hidden signal, angled just right, finally exposed. So why didn't NASA tell us? And what exactly is 3I Atlas hiding? And speaking of space mysteries, check the description for a link to cosmic gear I handpicked at Walmart, telescopes, binoculars, galaxy projectors, and more. Just weeks ago, 3I Atlas was nothing more than a passing curiosity for most of the scientific world, the third confirmed interstellar object to ever enter our solar system. And unlike the others, this one seemed quiet. A dim speck moving across the sky, cold and uneventful. No strange acceleration like Oumuamua, no coma or tail like Comet 2I Borisov. Just a visitor, silent, dormant, forgettable. But everything changed with a single image. And not from where you'd expect. Not from NASA. Not from the European Southern Observatory. Not from Hubble or Webb. This image came from a small observatory in Minas Gerais, Brazil. A place with no billion-dollar budget, no international spotlight, just a few powerful telescopes and a team that refuses to stop watching the sky. And what they found, no one saw coming. A tail, barely visible, faint as a whisper, extending from the core of 3I Atlas like a thin thread unraveling in space. And here's what made it truly bizarre. It wasn't pointing where it should. Comet tails always point away from the sun, pushed by the solar wind and radiation pressure. But this one was tilted 102 degrees off the solar axis, off-center, unexpected, invisible to those scanning in the usual directions. That one strange angle changed everything, because now this wasn't just a rock drifting through the void. It was active. It was shedding material. It was doing something. And that raises a much deeper question. Was 3I Atlas ever dormant? Or were we just looking at it the wrong way? While NASA's James Webb had already mapped its chemical composition, what this Brazilian team captured went beyond chemistry. It revealed behavior, transformation, and perhaps the final clue we'll ever get before this object vanishes behind the sun. A cosmic puzzle was unfolding, one piece at a time, and the next one was about to fall into place. In the southeastern hills of Brazil, far from any high-tech space agency or media headquarters, a small group of dedicated sky watchers were tracking the skies like they do every night. No fame, no budget, no headlines, just telescopes and patience. The SONEAR Observatory, or Southern Observatory for Near-Earth Asteroid Research, is not what you'd expect. It doesn't have deep funding. It's not tied to any international space program. It was built with one purpose: to find what everyone else misses. And on the night of August 23, 2025, SONEAR delivered. Veteran astronomer Cristóvão Jacques, a man with a long history of asteroid and comet discoveries, was observing 3I Atlas as part of a routine scan. The object had passed before, nothing unusual, but this time, something changed. The brightness seemed a little sharper. The data looked familiar, yet off. And then, there it was. A faint line, not part of the object itself, but just off-center. A slight, almost imperceptible streak extending from the core. Could it be a background star, a camera glitch, a processing artifact? To most, yes. But to Jacques, this was worth a second look. He called in colleague Ari Martin, director of the Pleitsdal Astronomy Club, who quickly ran an independent analysis. Frame by frame, image by image, they saw the same anomaly. A line, consistent, aligned, and definitely not random noise. What they saw was the early formation of a tail, a sign that 3I Atlas, long thought to be a cold interstellar rock, might actually be active. But here's the strange part. That tail wasn't trailing directly away from the sun, like every known comet. It was angled at 102 degrees from the solar vector, so far off the expected axis that traditional sky scans would have missed it completely. It was there, but it was hiding. The team could have waited, filed a paper, sent the data to a formal agency, but instead, they chose something bold. They released it. Immediately. No red tape. No embargo. They handed it to Schwarza, a Brazilian science communicator known for translating deep space science into language the public can understand. Within hours, the image and its implications spread through forums, articles, and headlines around the world. NASA hadn't seen it. James Webb had missed it. But SONEAR, this modest observatory in Brazil, saw what no one else could. And they didn't just keep it. They shared it, freely, openly, with a global audience that wasn't even looking. In that single act, they reminded the world that exploration isn't just about resources. Sometimes it's about perspective. And in this case, the most important cosmic clue didn't come from above. It came from below, from Earth, from those who never stopped watching. In the world of astronomy, some rules are nearly universal. One of them is this: comet tails always point away from the sun. That's not just a pattern, it's physics. As a comet approaches the inner solar system, the sun heats up its frozen surface. The ices begin to sublimate, a process where solid turns directly into gas without becoming liquid. This releases streams of dust and vapor into space, creating a glowing cloud called a coma, and eventually a tail. And that tail, it always forms away from the sun, pushed by solar radiation and charged particles from the solar wind. It's so consistent. Astronomers use tail direction to figure out the orientation of comets in space. But 3I Atlas didn't follow the script. When Jacques and Martin studied the Brazilian image from August 23rd, they noticed something impossible to ignore. The tail wasn't behind the object. It wasn't pointing directly away from the sun either. It was tilted, angled 102 degrees from the sun's axis. That's not just a slight misalignment, it's a complete break from normal geometry. So how did we miss it? Because our expectations blinded us. Astronomers, professional and amateur alike, are trained to scan the skies in predictable ways: east to west, sunset to sunrise, linear paths. And when looking for comet tails, they follow a simple rule: check the direction opposite the sun. But 3I Atlas had other plans. This tail didn't behave like a kite streaming in the wind. It emerged sideways, seemingly from nowhere. Why? Because of how Earth was positioned relative to the object, and how light interacts with particles in space. Let's use a metaphor. Imagine you're looking down a long hallway. Someone walks toward you holding a flag behind their back. From your view, the flag is hidden, perfectly aligned with their body. You don't see it until they shift just slightly to one side, and suddenly the fabric unfurls. It was always there. You just couldn't see it until everything lined up. And it's the same when we lift our eyes to the sky. The universe's secrets reveal themselves only with the right tools. In the description, you'll find a special selection: telescopes, binoculars, galaxy projectors, shirts, and more space-inspired pieces. That's what happened here. The tail wasn't invisible. It was simply misaligned from our perspective, and it took the perfect combination of Earth's orbit, the sun's angle, and the object's orientation for it to become visible, even faintly. This is why the Brazilian discovery is so significant. They weren't just lucky, they were looking without bias. They weren't bound by institutional blind spots or expected geometry. And when everything lined up, light, movement, timing. They caught the moment where the invisible became visible. So what does a sideways tail mean? It means 3I Atlas is not passive. It's responding to solar energy. It's active in a subtle but undeniable way. And that one faint streak, tilted and easy to miss, just redefined how we understand interstellar visitors. The appearance of a tail, especially one that breaks all the rules, demands more than just curiosity. It demands interpretation, because in astronomy, a tail means one thing above all else: activity. Let's be clear, comets don't have engines. They don't steer, they don't think, but they respond. When the sun's radiation hits a comet's surface, the frozen gases inside begin to sublimate. This reaction, solid turning directly into gas, creates pressure, pushing dust and vapor outward. That's what forms the coma and the tail. And that behavior tells us a story. The object is not dead. It's reacting. It's evolving. Now here's where it gets really interesting. Weeks before the Brazilian discovery, scientists had predicted that if 3I Atlas had any volatile materials, like water ice or carbon dioxide, its activity would likely begin around mid-August. The Brazilian image was captured on August 23rd, right in the predicted window. And although the tail was faint, barely above the noise threshold, it was oriented exactly in the direction consistent with the sun's position at that moment. That's not coincidence. That's confirmation. It validated what theorists had suggested. 3I Atlas was undergoing sublimation, just like a comet. Not wildly, not explosively, but gently, subtly. This quiet activity could mean the object is made of ancient ice, tucked deep below the surface. It may have taken months of solar heating before enough pressure built up to release even a faint stream of material. And this stream, this tail, tells us it's not just passing through, it's changing as it moves. Here's the problem: if this is activity, and if it matches cometary behavior, then why did earlier observations, like the ones from NASA, fail to detect it? Because this activity is just starting. It's a slow awakening. The object may have been dormant for millions or even billions of years until now. And the process is delicate. The moment of sublimation depends on surface composition, internal structure, rotational speed, and exposure to sunlight. It's not predictable with precision. It's more like watching an ancient machine slowly come back to life, piece by piece. And that leads us to a bigger question. Is this just a comet from another star system? Or is it something else entirely? Because tails mean activity. Activity means transformation. And transformation means energy is being exchanged. Which means, scientifically speaking, 3I Atlas is not inert. It's alive in the celestial sense. And once an object becomes active, its trajectory, its mass, and even its identity start to change with it. That's not just a scientific observation, it's a turning point. So now we know 3I Atlas isn't dead. It's changing. It's shedding material. It's behaving like a comet. But here's the real question. What is it? Because a tail might tell us how an object behaves, but not what it is. And the truth is, we don't know. Not yet. Let's look at the possibilities. Theory 1. It's a comet. That's the obvious answer. It acts like one. It's sublimating under solar heat. It's developing a tail. Case closed. Right? But something feels off. This isn't a typical solar system comet. It's traveling on a hyperbolic trajectory, a path that doesn't loop around the sun but escapes it. That means it's not from here. It came from interstellar space, moving too fast to be captured by our gravity. So if it's a comet, it's an interstellar one. That brings us to Theory 2. It's a planetary shard. Some astronomers believe 3I Atlas could be a fragment of a once larger planet, blasted apart by a cosmic collision in another star system. The irregular tail angle, the strange composition, and the delayed activity could all point to this. Think about it. What if this isn't just ice and dust, but part of a crust, or even a mantle, from a world that no longer exists, drifting alone through the void for millions of years, until now? Then there's Theory 3. It's something we don't have a name for, a class of object we haven't categorized, neither asteroid nor comet, neither alive nor inert, a hybrid, a relic, a cosmic fossil. We've only seen 3 interstellar visitors so far. Oumuamua in 2017, fast, tumbling, no visible tail. Tuai Borisov in 2019, clearly cometary. And now, 3I Atlas, somewhere in between. Each one challenged our understanding. Each one left us with more questions than answers. So where does 3I Atlas fit? Its motion is comet-like. Its composition is complex. Its tail is subtle, misaligned, and only recently detected. And its path, straight out of another star system, which leads to a much deeper question. Are these objects messengers? Not in the science fiction sense, but in the natural one. Each of them carries the materials, the chemistry, and the physical scars of their home systems. They're like pieces of other worlds, drifting across light years, landing briefly in our view, then vanishing forever. And the fact that 3I Atlas chose this moment to wake up right before disappearing behind the sun feels poetic. As if the universe gives us only a glimpse, just enough to spark wonder before pulling the curtain back again. Whatever 3I Atlas truly is, one thing is clear: it's not just passing through, it's leaving a trail of evidence, and we've only just begun to interpret it. In the search for truth, sometimes it takes more than one pair of eyes, and when it comes to 3I Atlas, 2 very different perspectives collided in a way that few expected. On August 6th, before the Brazilian discovery, NASA's James Webb Space Telescope aimed its unmatched infrared instruments toward 3I Atlas. Its mission, not to take pictures, but to decode light. James Webb doesn't see in the traditional sense. It reads spectra, the chemical signatures hidden inside infrared light, invisible to the human eye. What it found was surprising. Webb detected traces of water ice, silicates, and, most notably, an unusually high concentration of carbon dioxide, CO2. So high, in fact, that it rivaled the atmospheric levels found on Mars. This raised serious questions. Why so much CO2? That's not typical of most comets we've seen. Could this be a piece of a planetary body that once had an atmosphere, or something chemically unique from a solar system unlike our own? The Webb data was precise, but also incomplete, because while it told us what 3I Atlas is made of, it told us nothing about what it's doing. No motion, no structure, no tail. Webb's field of view is narrow, designed for depth, not scale. It's like a microscope looking into the heart of the object, but blind to its outer behavior, and that's where SONEAR steps in. From a modest observatory in the mountains of Brazil, with far less power but a wider field of view, SONEAR did what Webb couldn't. It saw movement, it saw structure, it saw the tail, not just a list of elements, but a living behavior unfolding in real time. So, which one is more important? Both. Together, they create a kind of cosmic stereo, 2 perspectives, 2 senses, 2 truths, revealing different dimensions of the same object. Webb told us the ingredients: frozen water, silicates, and carbon dioxide. SONEAR showed us the reaction, a faint, tilted tail that proved those ingredients were being activated. Webb gave us the what, SONEAR gave us the how. And only when you combine both do you get the full picture. That's the beauty of science. It's not about one perfect tool. It's about many tools working together, each seeing something the other can't. And when that happens, something extraordinary emerges. 3. Atlas isn't just a rock flying through space. It's a message written in light, chemistry, and motion. And it took both space-age technology and human curiosity to start decoding it. And yet, even with all this knowledge, we're running out of time. As more and more data emerges, so does the realization that this moment won't last. Our window into the mystery of 3I Atlas is closing fast. In just a matter of weeks, the object will pass behind the sun from our point of view. Astronomers call this a period of solar conjunction, when an object becomes hidden in the sun's glare and completely unobservable from Earth. And it's not just a technical inconvenience, it's a total blackout. During this time, even our most powerful space telescopes can't observe the object safely or effectively. That means no more tail analysis, no more chemistry, no more tracking, just silence. And by the time 3I Atlas reemerges from behind the sun, it might be different, colder, fainter, possibly even inactive again. We might never see that strange angled tail again. We might miss its most critical phase, right as it reaches peak activity. Think about that. We caught it just as it began to wake up, like seeing the first flicker of light from a candle before it burns out. Forever. This is not a slow-moving opportunity. 3I Atlas is fast, moving at tens of kilometers per second, too fast to stay, too far to follow, and too rare to waste. It's not just that it's disappearing behind the sun, it's that we may never get another look this close, this active, this raw. We've had only 3 interstellar visitors in human history. 3. One showed no tail, one was clearly cometary, and this one, 3I Atlas, is somewhere in between, defying expectations in ways we're just beginning to understand. The stakes are high, and the time is short, because the universe doesn't wait for us to get ready. It offers brief windows, tiny slivers of clarity, and then they're gone. And if this object never becomes active again, if it slips into the shadows of space, never to return, then this image, the one taken by an overlooked observatory in Brazil, might become the only lasting visual memory of a cosmic traveler millions of years in the making. A grain of dust from a distant star, a message in motion, and we almost missed it. Almost. Some people might ask, why does this matter? It's just a rock, right? A frozen object from deep space. Just another scientific curiosity, but that's the surface level view, because discoveries like this are not just about space. They're about perspective, about what it means to live in a universe that is far older, far stranger, and far more mysterious than we were ever taught to believe. 3I Atlas didn't arrive with fireworks. It didn't send signals. It didn't change its course or crash into a planet. But it whispered. And for those watching closely, that whisper spoke volumes. It told us that even in a world saturated with technology and algorithms, there is still room for wonder, still room for raw human curiosity. It reminded us that the tools of discovery don't always come from billion-dollar programs. Sometimes they come from humble observatories on quiet hills, from passion, from people who still look up, not because they're told to, but because they can't help it. It also showed us that science is not a finished book. It's a story being written in real time, and sometimes the plot twists don't come from the centers of power, but from the edges, from unexpected voices, from distant places. Think about it. NASA gave us the chemical DNA of the object. SONEAR gave us its behavior, and somewhere in between, we're beginning to glimpse its identity. an interstellar traveler that waited millions, maybe billions of years to pass through our solar system, and in that fleeting moment, it did something. It moved. It reacted. It changed. And in doing so, it offered us something rare, a glimpse, not just into space, but into ourselves, into how we search, how we interpret, how we choose to see meaning in the silent patterns of the sky. Because the universe doesn't explain itself. It doesn't tell us what's important. We decide that. And when a single image, captured by a small team on a quiet night, can shift our entire understanding of a cosmic object, that's not just a scientific event, that's a human one. So yes, this matters. Not because 3I Atlas will save the world, not because it reveals alien life, but because it proves we're still listening, still wondering, still reaching into the dark, hoping to find something new. And this time, we did. The cosmos still holds secrets. In the description, you'll find my space-inspired pics. But the mystery of 3I Atlas doesn't end here, because in the latest data, something even stranger appeared. Not just a tail, not just a signal, but a pattern hidden in the light itself. If you thought this was unusual, wait until you see what we found next. Click here before it disappears too.